Okay, so we're going to take a look at rational functions. Okay, the last functions we're going to take a look at for this course. So rational functions, the word rational kind of should bring to mind maybe a fraction. So anytime we have some sort of a constant, I guess, or actually a rational is kind of a polynomial over a polynomial. All right, so in the very simplest form, we'd have 1 over x. That is the simplest rational function there is. Okay, because polynomial could just be a number. It's rare that it is, but it could be. And of course, this has to have an x, so there's our x. Okay, so that's a rational. All right, if we have an x over an x minus 1, that's a rational. And anytime we have a polynomial over another polynomial, it's a rational. Those are all rationals. We just can't have functions on the top and a function, so to speak, like a log. Okay, that's not really a rational. It's more a polynomial than it is something else. All right. So when you graph these, you get some peculiar results as to what this thing is. All right. So what we're going to do is we're going to graph these, and we're going to introduce some sliders. And I'm going to kind of have you do the same thing I had you do before a little bit with some polynomials, just kind of noticing some things. All right, so for example, we're going to take a look at this. So we're going to graph, and I'm just going to put a 1 on the top there, and then we're going to introduce a slider for A. All right, and we're going to take a look at that. All right, then, you don't have to write these down because I'm just going to put them in decimals for you. Then we're going to say, well, what happens if we have, we can leave this A here. And what if we have 2 things on the bottom? Okay, and then we're going to talk about that, and then we're going to say, well, what happens if we have something on the top, say an A, and then we have something on the bottom? Okay, so these are all the different scenarios. I mean, there's more that we're going to investigate. All right, so we're going to set that up in decimals, introduce some sliders. Okay, so let me set that up for you. And then you can look at them, and then when you're done, your reward would be you can take a break. Okay, so here we go. So the first one's going to be 1 divided by parentheses x minus a, and we're going to introduce a slider there. All right, so what we have is we have this curve, okay? And we can zoom out and you can see this kind of bending. That's what we say, bending. All right, and we can slide this around and see what happens. Okay, that's what I kind of want you to do, is just kind of notice, okay, well, this graph is doing this and this is what I see. Then after you're done with that one, click off of it so it doesn't confuse you, and we'll put this one in. Y equals, let's go with, I'm just going to go parentheses x minus, and maybe we should stay away from, well, we can still use a, I guess, because it doesn't matter. Divided by parentheses x minus, and let's put a b in there this time. And we're going to add a slider b. So now we're going to add, so we got 2 sliders for you to play with and see what happens on that one. Okay, and then I'm going to put this one in. We'll keep the A on the top. And we'll put 2 down here on the bottom. We'll use B. I would turn these off when you're done so you don't get confused with what's going on. Okay, so I think what I'm going to try to do, well, I'll just leave it like that. Let me get rid of this one. Okay, so here, let me put these there. So we have 3 of them to work with, all right, for right now. All right, so start with this one, play with A. Start with this one, play with A and B. See, there's some things you're going to notice there. It's going to be different. Same thing on this one. All right, play with those things. See what you come up with. When you're done with some, kind of, I don't know, maybe jot a few ideas down, what you notice with those, and then we'll talk about them. Okay, and go from there. I'm going to go run that stuff off. We have a graph that looks like this. So it looks kind of like this, and this thing here, Ryan says, well, that's my vertical asymptote. And it's at wherever A is. Okay, so if A is 3, then its vertical asymptote is at 3. Okay, if A is -4, then the vertical asymptote is going to be at -4. So this is a vertical asymptote. That graph is bending. Okay? Bending. All right, let's look at this graph. I think actually we had I put a value up there, like x minus c. There we go. Okay, so this is the one that we just did. Now this one could have how many vertical asymptotes? Could it have? How many could it have? This is the last one that we did. What did we notice? How many vertical asymptotes?
2.
2, right? It could have 2. So it could be here and here. Okay, something like this, something like this. Okay, something like that. All right, so 2 vertical asymptotes. Two vertical asymptotes, and they would be at x equals A and x equals B. That's what's on the bottom. All right, remember the key idea is whatever makes the bottom 0, and because that's where the issue is going to be. All right, whatever makes the bottom 0. So those are where my vertical asymptotes are. And that's just one example of what it could look like. There's some other ones, too, that it could look. All right. But there's a possibility that this graph could look like this. And we would have 1 vertical asymptote. But what else is happening there then? Because we only got 1 vertical asymptote, but we got two things on the bottom. So what else is going on there?
That means we have a hole.
That means we have a hole. Okay, so we have a vertical asymptote and a hole. And that happened when what has to? In order to get a hole, what do we got to have? See, that was x minus c. X minus a and x minus b. Okay, in order to get that whole, right, what has to happen? You're close. Not x has to be equal to a. What has to be equal to a? C, right? So these two things here, okay, this and this one, all right, have to be equal, all right? So to get a whole, then our whole would have to be when C is equal to A or C is equal to B. Then we're going to get a whole, all right? Wherever the whole is, oops, the vertical asymptote is not going to be, all right? So it's either going to be where C is equal to A or C is equal to B. What happens then, all right, is we get something like this. And those cancel out. Okay, kind of like Ryan was saying, where you're going to get a 1 over 1 or something like that, where those are going to cancel out. Okay, then we're going to get a whole. All right. Okay. Kind of crazy. That's what's happening with rationals on that. All right, let's go back to this one. Okay, so this was another one that we did, which was like the second one. So in this one, we could have a vertical asymptote. But what else could happen? Well, we haven't talked about that, but that's the next thing. You're right. So we can have a vertical asymptote, but what else could we have in this situation where we have an x minus a over x minus c? What happens if c and a are the same? We're going to get a straight line because we're getting what? Instead of a vertical asymptote.
Didn't that 1 over 1?
Which gives us a... Right, but there's got to be a hole there, okay? So when C and A are the same, all right, if C equals A, that means we're going to get a hole, okay, at C. If C and A are not the same, then we get a vertical asymptote. At C. All right. So that's our situations. We're either going to have vertical asymptotes or we're going to have a hole. All right. You're always focusing in on the bottoms because the bottoms are going to tell you where the vertical asymptotes or holes are because we can't have 0 down there. It's possible we could have 2 vertical asymptotes, we could have 3 vertical asymptotes, have as many as we want, but we're either going to have vertical asymptotes or we're going to have holes. Those are called discontinuities. All right? They don't really put that in the book, I don't think, but that's what they're called. Okay. So we're going to come back to this, so I'm going to switch back to here. Now, Josh mentioned something here. Let's talk about that. Nobody noticed said anything to me about there's something here but there's also a flattening out of this curve, okay, as we zoom out. So at the same thing, let's go back and title this f of x again. Get rid of this f of x, I think, like that. Okay, so now I'm going to change these values so that I'm looking at numbers that are way out here. So I'm going to go with 10, I'm going to go with 100, I'm going to go with 1,000, I'm going to go with this, 10,000, okay? And we can see that this is getting smaller and smaller. This is, I don't even know, 10 to the negative something or other. Very, very small. So what number is that getting close to? It's getting very, very small. It's getting close to what number is it getting close to? What number is 1.002 times 10 to the negative? I don't even know. Here, 7. Negative 7. Okay, so what number is that really close to? 0. All right, it's flattening out at 0. Same thing happens on the other side if we do the exact same thing. All right, these guys are getting very, very, I don't think I can make this any different by doing that. I don't think I can make it any different by doing that. Okay, so these are getting close to 0 also. All right, close to 0. Okay, so this has a flattening out horizontally, which is called our horizontal asymptote. All right, flattening out, flattening out. Right. All these have horizontal asymptotes. Let's come way down here. Take a look at this one. All right, another horizontal asymptote. Okay, even if I take and do this, and take and do this, all right, they're flattening out. They may be flattening out at different values, but they're flattening out. So if I make this a 2, all right, and this a 2, there's my hole, there's my horizontal line at 1. As soon as I change this to something, there's my horizontal line. Now it becomes an asymptote, okay? And it's at 1, all right? It's at 1. No matter how big I make B, it's always going to be at 1. This one, let's take a look at it. Okay, and let's play this guy. So here's our, again, horizontal asymptote. Okay, now it's interesting because, let's see if we can pause this right here. And pause this one right there. So you see, you can cross your horizontal asymptote, that's okay. We're only interested in what's happening out here at the very ends. All right. So that's a horizontal asymptote. So these guys have vertical and horizontal asymptotes. Horizontal, vertical, asymptotes, and holes. Okay. So what we got to do is be able to take, and if you take a look at that final review, the first question on there is talking about rationals, and it's saying, hey, find the horizontal, vertical asymptotes, holes, domain, okay, those kind of things. That's what you're going to have to do. So let's do that. So let's take some, all right, and let's work through them. So we'll start off with this. Now you should be able to do this without even graphing them, okay? But if you have to graph them, go ahead. But you should be able to do this without graphing. All right, so let's talk about this right now. So let's talk about the domain. What can't the domain be in this situation? -4. Can't have a 0 on the bottom. All right, we did some of these when we were doing function composition, and I said, well, this is a rational, but we don't talk about rationals to the end, and here it is, the end. So we're talking about rationals, okay? But they assumed that you knew that you can't have a -4, all right, because that gives you a 0. All right, there's my domain. Does this have a vertical asymptote? Yep, we're at. It's like -4. Now you should be able to do that without graphing it, because if you look at the bottom, no, the bottom can't be 0. That's where my vertical is. Automatically, you know that. Vertical asymptote's at -4. Okay, a little harder for the horizontal. Okay, so horizontal asymptotes will be y equals. Remember, we're interested in what happens at the very end. So if I put a big number in here, like 1,000,000, I'm going to have 3/1,004, which is going to get really close to what number? 3 over a very, very large number is going to get close to what? 0. Bingo, there it is. Domain, vertical asymptote, horizontal asymptote. We did it. Right? You don't even have to graph it. You should be able to look at this and get an answer. Now, I'm not saying you can't. I'm just saying if we want to get to where we don't have to. All right, and the graph is just a check.
Is the horizontal one always equal to y equals 0?
No. Okay? We'll do some that's not. Okay, here we go. Domain. Vertical asymptote. I'm just going to abbreviate it VA. HA for horizontal. Okay. What's the domain? What can't X be? 2 and -1. All right. If anybody has any questions, you can ask Josh. He has all the answers there. He knows this stuff, huh? Okay. 2 and -1. Okay. Now, vertical asymptote. First of all, does this have vertical asymptotes? Are we pretty sure of that? At the bottom. We got vertical asymptotes. Yep, we do. 2 and -1. Okay, 2 and -1. There's our verticals. All right, notice that the domain and the vertical asymptotes are kind of related. All right, you should kind of pick that up. Oh yeah, I see that. That happened on the last one too. All right, so we're going to think about the horizontal. Again, we're going to put a huge number, so I have 1,000,000 minus 1, which is darn near 1,000,000, and 1,000,000 times 1,000,000. So we have 1,000,000 over 1,000,000 squared. Okay? You might think, well, shoot, that's a big number over a big number. Yeah, but one of the mills is going to cancel. and leave us just 1 over a million, which is pretty dang close to 0 again. All right? Okay, and we're going to go back and review this, and we'll look at horizontals from a different approach too. All right?
To find the horizontal asymptote, you just plug in a large number for x.
That's one way. I'm going to show you a different way here in a little bit. Okay? That's done. All right? Let's try another one here. So we're going to go with x plus 2 on the top. Okay, here we go. X plus 2 over x minus 3x plus 2. Domain, vertical asymptote, horizontal asymptote. What can't the domain be? -2 and what else? So we got +3. We got 2 things on the bottom, okay? Domain can't be those 2 things, -2 and 3. All right, vertical asymptote. Do we have any? 3. Well, what about this 2? It's got to be a hole. Why? Because these 2 things are the same or canceling out. Okay? That's where the hole is. So if you got 2 things canceling out or they're the same, that's going to be where your hole is. So then you're going to come over here and go, oh, okay. So now I have a hole at -2. Okay? Now I know I got to have 2 discontinuities because my domain doesn't exist in each part. So this is a 3. That's my vertical asymptote. That means I got to have a hole. All right. Either I got 2 vertical asymptotes or I got a hole in that situation. Horizontal. Think of it the same way. All right, 1 million over a million squared. One of the millions is going to go. We got 1 over a million. So what's the horizontal asymptote going to be? Y equals 0. Right? If you're not sure, graph it. It's going to flatten out. Okay. So Kat asked me, oh, I thought you said that all the horizontal asymptotes weren't going to be 0. I thought you said that. Domain, vertical, horizontal. Okay, this one looks a little different. What can't the domain be? -3, we're getting better at it. Okay. Vertical asymptote or hole, what do we got? Vertical asymptote or hole. This should come a little quicker. But is it a vertical asymptote or is it a hole? Vertical asymptote. These things got to be the same. They're not even close. So it's not a hole. It's got to be a vertical asymptote. So then we write down here, vertical asymptote, -3. Sweet. Okay. Now let's look at this one. So go ahead and graph it and see if you can figure out what the horizontal asymptote is. All right. Toss it in, see if you can figure out what it is. How about 2? So now horizontal asymptote is not 0. Well, doing that same thing, if we took 2 million over a million, okay, we're going to get 2. Right? Did it level out at 2? Does it flatten out at 2? That's one way you can look at it graphically. If you graph this, okay, there should be a vertical asymptote here at 3, and then it should come on, let's see, it should have a, it should bottom out, it's got to be like, it's got to be, I might have this drawn wrong, but I know where that 0 is. It's going to be at -1/2, so it should be coming like this and like this, but that doesn't make much sense. Is that what it looks like? Yeah? Okay. So it should be flattening out right here at 2. Okay? And if I put a million in there, put a big number, I get 2 million because I don't worry about the 1, over a million because I don't worry about the plus 3. Million over a million cancels, leaves me with 2. Now, another thing to think about, if we took this top one, then we divided it by the bottom one, either using synthetic division or long division. Okay. X goes into X, that cancels, leaves us with what? 2. Yep. Leaves us with 2. Okay? So there's an example where we have a horizontal asymptote at 2. All right? Okay. I'm going to go back decimals and let's look at a few other ones in here and let's play with these. So I'm just going to get rid of this. I'm going to get rid of all this junk. Start with a clean slate. Yeah. I'm listening.
We have quiz right? So I should come in.
Yes. If we have a rational and I'm just making these up, so we'll go, what do we have on top? Well, we'll just put A here and B here. All right, so if the degree on the top is 1 larger than the bottom, okay, so A is larger than B, all right, such that A plus 1 is equal to B, so it's 1 more, all right, we're going to have what we call an oblique or slant asymptote. All right, so if the degree on the top is 1 larger than the bottom, you're going to get an oblique or a slant asymptote. If the degree on the top is larger, but it's such that A is larger than B, such that A plus 2 is equal to B, then we don't get any type of asymptote, but the shape approaches a parabola. if A and B are equal, so the degrees are equal, then that means that we're going to get horizontal asymptote of 1 or a constant. Not 0. So if A and B are the same, the degrees are equal, we're going to get a horizontal asymptote where y is going to be equal to some number but not 0. And then the last one is what happens if B is larger than A. Okay, so the degree on the top is smaller. That's when our horizontal asymptote is 0. So that's the situation. So you can use that rule to help you with finding horizontal asymptote. Okay? So let's just do some problems here. You can see kind of what you're going to be asked. All right, using all this kind of information. All right? Here we go. So, for example, again, in the first part on 3.4, they're going to ask you to find the domain. All right? Find domain. And they're going to give you some. So they're going to, most of them are going to be already factored for you. That's going to be nice. They're already factored. You don't have to do anything. Okay? You don't have to worry about asymptotes. All you want is the domain. Okay? What can't the domain be in this situation? -1 or +2. All right? If they give you one and it's not factored, and you should factor it. Okay? So you should take this bottom part here, and I'm going to say, okay, I'm going to factor that. All right? I don't care about top, but I'm going to factor that bottom. X squared minus 9. So you know what that is. X plus 3, X minus 3. Okay? Again, we're only interested in the domain. That's all it's asking you. So what can't the domain be in this situation? 3 or -3. Plus or minus -3. All right? So when they're like that, you should factor them. Okay? In fact, if you look at the book, it's going to say factor these first. All right? Factor them first. That's what it's going to ask you. Now it's going to ask us to find vertical asymptotes, horizontal asymptotes, poles, domain, obliques, okay? And they're just going to give you some, and so you just got to look at them. So if we have bless you. Okay, domain first. All right. What can't the domain be? What can't the domain be?
-1.
-1. Can't be -1. Look at the bottom, right? Whatever makes the bottom 0, domain can't be that. All right? Now, we're going to do this without graphing. Watch how easy this is going to be. Vertical asymptote or hole. What do we have in this situation? Vertical asymptote. Okay, they got to cancel in order to be a hole, and nothing's canceling. So where's our vertical asymptote at? -1. Not even graphing it. Okay? What domain says it can't be -1, so that's got to be my vertical. Alright? So, I got this done, I got this done, and I got this done. Alright? Let's look at the degree. What's the degree of this guy? 2x. What's the degree right there? What's the degree of this? They're both 1. Well, if they're both 1, then what did we say the horizontal asymptote has to be? If they're the same, what does the horizontal asymptote have to be? 1 or a constant, right? Okay? So if we divide this, x goes into x, cancels out, what's left? 2. There's your horizontal. Okay? So we're doing all this without graphing. So we don't have any holes, we don't have an oblique, we're done. All right? We did all that without graphing it. That's the whole idea. Y equals 3x squared over x squared minus 4. All right? So, we should factor the bottom part here. That helps us. We don't care about the top. Okay. Domain, vertical, horizontal. What can our domain not be? Plus or minus 2. Do we have vertical asymptotes or holes? Do we have any holes? Does anything cancel out? Nothing's canceling out. There's no x minus 2's on top, so those are both vertical asymptotes. Okay? If you're not sure, you can graph it, but you should be able to do it without graphing. Okay? Look at this again. The degree is the same. So where's our horizontal? 3. There you go. Okay? There you go. All right? Okay, here's another one. X squared minus x minus 6. Okay, again, we should factor this because that's going to help us. So we got to factor this top part. Bottom's done for us. We don't need it. X and x. What's going to be our factors on the top? X and x. Very good. 2 and 3 gives us negative 6. That's what we want. Okay. What can our domain be? Domain cannot be 3 and negative 2. Okay? What do we have in this? Do we have a vertical asymptote? Oh. Yes or no? No. No vertical asymptote. Okay? What do we have instead? We have a hole. Where at? 3. Very good. Okay, that's the thing that's canceling out. The x minus 3's are canceling, so that's where a hole is. All right?
Negative 2 included in the domain restriction.
Oh, I don't know why the negative 2 is recorded. That's the dumbest thing for me to do. Thanks. Okay, domain's can't be 3. All right, hole's at 3. Horizontal asymptote. Let's look at the degree. Does this have a horizontal asymptote? And what is it?
2.
Oh. Look at the degree. What's the degree at the top?
2.
What's the degree at the bottom? This is larger. So what does that little rule tell us then?
So it's slant.
So it's a slant or an oblique. Okay? This one has an oblique. All right. Now, on the final, I'm not going to ask you to tell me, I'm not going to say, tell me what it is. All right? But in this case, actually, this doesn't even have an oblique. I think it's just going to be a slant line, and the 3's are going to cancel, and it's going to be x plus 2. All right? So it doesn't even really have an oblique. It's just going to be a regular old line at x plus 2. All right? But if it did have an oblique, then you don't have to tell me what it is. You just got to say, it has an oblique. Okay? That's all I'm looking for. All right? So these questions, this is what's going to be, this is the type of stuff that you're going to get to do on your assignment and on the final. All right? It's just going through and analyzing these. Now, they're going to ask you on 255, it says follow steps 1 through 7 on 246. Okay? Basically, you can do that if you want to, but they're just asking, telling you to factor it and do some intercepts and all that stuff. Just go through and do what we're doing. Okay? Don't worry about the steps there. Just factor it, find the domain, find the vertical asymptotes, find the holes if they exist. Okay? That kind of thing. That's all you got to do. If you're not sure, then graph it. Okay? Just graph it and see what's happening. All right, on these. If you're not sure, just graph it. All right? Now be careful because this assignment, it's quite a bit. All right, but we want to try to get it done Wednesday. So, and I guess if you don't get it done by the time you show up here Wednesday, you can work on it Wednesday when you come to class too, because we don't have anything going on. All right. So that kind of gives you a chance to do some. Don't know what you're doing? Come in Wednesday. I can help you. We can go through some more. All right. But that's pretty much all the stuff on rational.